I will inform you.
Just wait, because I will inform you. Live streaming.
You can start now, Aparna.
Okay, sir. Our intelligence is what makes us human, and AI is an extension of that quality. The coming era of artificial intelligence will not be the era of war, but the era of deep compassion, non-violence, and love. A very good evening to all. I feel privileged to extend my warm welcome to one and all present here for the Day 2 International Online Faculty Development Program on Perspectives of Artificial Intelligence Application on the behalf of Department of Electronics and Communication Engineering in St. Joseph's Institute of Technology. I am Aparna Devadas, here to host today's session. Our limitation, it's only our imagination. On this pleasant evening, it gives us immense pleasure to cordially welcome our guest, Dr. Mohanraj Venkatachalam, as our honorable speaker. We would like to extend our gratitude for accepting our invitation and joining us to share your knowledge. Welcome, sir. Our respect and gratitude to our chairman, Dr. B. Babu Manoharan, sir, our managing director, Mrs. B. Jessipriya, ma'am, our respected principal, Dr. P. Ravichandran, sir, our director, Mr. B. Sasishekhar, sir, who has always been a great source of inspiration to all of us. It also gives me immense pleasure to welcome the HODs of ECE department, Dr. C. Nyanakausalya, ma'am, and Dr. G. Rohini, ma'am, and all our ECE staff members. Last but not the least, I welcome all the participants. Welcome you all. Here are a few words about our speaker. Dr. Mohanraj Venkatachalam pursued his Bachelor of Engineering and Master of Engineering in Computer Science from Anna University, Chennai. He completed his Doctor of Philosophy in Computer Vision, Video Analytics and Deep Learning from Madras Institute of Technology, Anna University, Chennai. His research areas include computer vision, video analytics, and deep learning. His research was funded by Department of Atomic Energy, Government of India. He is currently working as a data scientist and industrialist in Advanced Technology Group, Chennai. He also worked as a data scientist in HCL Technologies. Some of his publications include hybrid feature descriptors to detect face-spoof attacks, robust face recognition system in video using hybrid scale invariant feature transform, a novel transform approach for face recognition under varying illumination condition. Before getting into the session, I have few instructions to the participants. Participants, kindly mute your mic and video. Kindly post your queries in the chat box, which would be answered at the end of the session. Also, the feedback link will be provided at the end of the session. I consider it a great honor to have Dr. Mohanraj Venkatachalam, sir, with us today. We are glad and eager to begin the session, sir. I request you to start the session, sir.
So I've shared my screen. If someone confirms so that I can start.
Yes, sir, it is visible.
Okay. Yeah, thank you. So very good evening, everyone. So I'll be going to talk about another 45 minutes to 50 minutes about how we are trying to solve the business problem with respect to some of the industry like automotive and even medical industry, some of the business use cases I'm going to discuss. And before I go into the some of the business use cases, quickly I'll just have a walkthrough on the traditional approaches and the machine learning approaches. Quickly consider an example here. The use case here, the applications here, human activity recognitions. So like person walking is a one activity, and running and doing in some cycling or playing and golfing activity, right? So in traditional approaches, like we have to give two things as an input, and one is a data and the other one is a rule. Okay, so here the rule we consider as a speed, and the data is an image. Okay, so based on the data and the rule, we'll be able to get the output variable. So output in the sense what category it belongs to. So given on data and the rule, the machine will classify what category it belongs to. Similarly, machine will categorize as a running and categorize as a cycling. And so in this case, the problem with the traditional approaches is that where we'll not be able to extract a speed on all the situations. So in this case, if the person is playing in golfing, or he is playing on cricket or some kind of these are the the data dependent, where we will not be able to extract the rule at all. So one quick example with respect to the traditional approaches, the drawback is that where we need to write hundreds or thousand lines of instructions. Suppose if I'm having a 100 category which I want to classify, then your instructions are the control statement is going to increase, right? But what we are going to discuss now, which is a machine learning approaches, which is basically two things here also we have to give as an input. One is an output variable, and the other one is an image, which is the input data. Okay, these patterns and the rules will be extracted by the machines. So only thing is that we need to feed n number of several sample data for each of these activity. Like person is walking, maybe you can consider thousands of data, and then you have to say all those 1,000 images belongs to which category. So you will give all these set of data for how many set of activity. First you need to define what is the business use case. For those business use case, you need to have a data in a structured format. So structured format in the sense, like here I have assume that I have a 4 kind of human activities. So you need to have a folder such as saying that walking, set of person walking, you need to have the all these collected images, data collected images, training data. You need to have a folder structures, and then you feed all this data, and then the machine start extracting all these unique patterns. Okay, so if you look at here, these are the binary patterns. These are the unique in the natures between the one activity between the others. So in this case, one of the advantages that where we'll be able to extract a rule or the patterns for all kind of activity, but where in case of the traditional approaches, where we'll not be able to get a speed or rule at all. So one quick example, if I want to say about, like you say that there is a mathematical equation. Assume that there is a mathematical equations which is a y equal to 2x plus 1. Okay, so in this case, y is the output variable and x is the input data. Okay, so now in this case, 2x plus 1 is the rule, the mathematical equations which we call is a rule, and the data is a set of x. So by solving the set of x, by feeding the set of x value to the mathematical equations, where you will be able to compute the y value, right? So the same thing what we can say with the machine learning approach is that you give the x vector and the y vector, input and output variable. These mathematical equations will be derived by the machines basically. So here the mathematical equations, we call it the feature vector. All these feature vector are distinct or unique between one of these activity. So we'll see much more use cases in detail. So some of the use cases with respect to AI or the machine learning, or it may be deep learning. So I am more into video and image analytics. Very few business use cases. Even I work on the text analytics as well. So simple use cases with respect to the machine learning or AI. Most of us we use emails, right? So how does it automatically categorize our email inboxes into social and general, right? So what happens in this case? The machine has the knowledge representation or knowledge understanding of like if the email, we assume that we convert the email messages into one word vector representation. Word vector representation in the sense you should have the unique number of words in the dictionary, and then you try to count in your email boxes which are the words are frequently appearing, the count vector, and the machine has the count vector knowledge representation for the general, and which are the email boxes are social. Like if your email boxes, assume that it comes from the Facebook or LinkedIn or Twitter, there may be keyword Facebook or some kind of the unique keywords between the general and the the social medias, right? So basically what happens in this case, whatever it may be machine learning approaches, so what you are supposed to do, you have to feed the n number of data to the basically to the missions. Quickly I'll show you one example which I want to talk about. So I stopped my screen, I'll come back. So if you look at here, this is a simple example with respect to the neural networks, or it may be deep learning systems. So what is going to happen here? You try. So here the example here, the intention to classify by the machine whether the handwritten digit is 8 or not. Okay. So for these use cases, so we have a set of n number of sample data by the different persons who has written the digits 8, because you should not collect in the one single environment, because it should work in the any person. If they write a digit, your machine supposed to classify what digit it belongs to. So what we supposed to do, we have to collect the handwritten digits of different person writing in a different angle, and then you have the other than digit 8. So it's going to be a binary classification, so whether given digits 8 or not. So we have a set of data for the given digit is 8 and not 8. Okay. So now what we are going to do, whatever whatever it may be, so we are going to have a no basically the training phase, and other one is in testing phase. Okay. So it may be machine learning or it may be deep learning. In the training phase, what we are going to do with respect to deep learning, we'll be having two things. One is the feed forward phase, and other one is in backward phase. So I'll talk about it little later. So in the training phase, what we are going to do, we are going to feed all these set of data which belongs to digit 8, not 8. So we are going to assume that I'm taking one of the digits from this training data. I'm feeding into the deep learning system. The deep learning system will predict the digit belongs to some no numbers. Assume that so it predicts as a 1. So 1 in the sense it belongs to a the category digits 8. If it is a 0, it is not a digit 8. So as I said, it's 1 belongs to true classes and 0 belongs to a false or negative classes. Okay. So now what is happened here? The given digits 8 and machine is predict as a 1. So what we supposed to do? We supposed to calculate the error or the loss once you compute at the predicted results. So what happens? I have given the digit 8 and the deep learning systems has predicted as a 1, and the actual input will be having a ground truth data. So with the ground truth data, what we supposed to do? We supposed to calculate the error. So here the predicted value and the actual value are same, then the error will be 0. But initially, machine will not predict as the proper the output variable. There will be some loss or error value. So what you are supposed to do? You are supposed to back propagate to the network. So basically, the deep learning systems will look like here. That neural networks are a deep learning architectures. So we'll have a set of input and output layer. So in between this set of input and output layer, we'll be stacking a number of hidden layers, and then we'll give the input, the training data to the input layer, and then the subsequent layer output will be passed on to the next layer in the network, and then the final layer will predict the output. And then, so in each of these layers, there is a parameter called weight vector. So that will get initialized randomly through n number of iterations and the epochs. By feeding the n number of sample data, we'll be deriving those W vector by training these deep learning systems. Okay. So now assume that I have trained my deep learning system or a machine learning system for a number of iterations. So once you have the trained model, so what we are supposed to do with the testing phase or the inference or the validation phase, you give some unknown or the test data. The deep learning systems try to predict what it belongs to. So it will say whether it's a digit is 1, or it will say the digit is no, not 8. Okay. So in this case, what happens and at the inference phase after training the model, I'm giving some unknown data. The machine is giving the probability of 0.9. So we'll have a certain threshold. So above certain threshold, like 0.5, we say that it's a positive class. Less than 0.5, we say it's a no false classes are not 8. Okay. So one, I request, I think someone, can you please go on mute? Okay, thank you. So I'll show you one demo. Is there a screen? That's the basic question. So if you look at here, this is another use cases which I have built it for basically to detect whether the person is wearing an face mask or not. So this is also kind of binary classifications, we can say. So we have to feed the machine learning or a deep learning models. So basically, which can categorize the given or the detected. So from the live video stream, basically we need to locate the face ROI. From the located face ROI, we have to go for a further classification, saying that the person is wearing a face mask or not. Okay. So in these certain use cases, because now it is important in a pandemic situation where no we have to classify whether basically to validate whether all the persons wears the face mask or not. Quickly, if you look at here, this is what we called as the structured data. So have a set of no face mask, weird face mask images, and then I have categorized all these images are no categorized output, categorized or labels into a with face mask, and I have a set of face images where categorizing into a without face images. Okay, so this set of structured data goes to a deep learning systems, which I have shown you earlier. And once we have this trained model, and then we can give some live data, or it may be a you can give from the live data video feed, we are supposed to detect face images, and the detected face images goes to the trained models. So in this case, there are two phases. The first phase, we supposed to detect the face images, because we cannot give the full frame to the the deep learning or the machine learning models, where we supposed to give the only the cropped face ROI to the models. Okay. So quickly, I'll go into the about the machine learning, or it may be deep learning, specifically image and video analytics. So we discussed about some of the business use cases, like a person wearing a face mask or without face mask. So how the machine is going to understand if some images, if I'm going to feed it to the machines, how it is going to understand this particular image is a person with face mask and without face mask, right? So because if you how are we going to represent the images to the machine? It's basically it's going to be a 2D array with the n number of pixels in the rows and columns, right? So if you look at here, there is a 2D array for cat and dog, right? So these are the simple example for the representation of images to the machines. So usually it's going to be a 2D array. But how the human brains capture some images through the eyes, and it looks at the several features, like if it is going to be an person, or it going to be an apple fruits. So we look at several features which are color, and it may be textures, or it may be some kind of shape. And then we say that because our brains are already seeing several data, so whenever we look at some new persons, we introduce each others, right? So that's what the our eyes capturing n number of sample data. And then when we ask the person what is his name, and then we say that name, we call it an output variable or the label value. So my brain has the data, the trained models. So whenever I look at the same person in somewhere else, and my brain automatically, so basically what is here happening with with respect to machine learning and deep learning. So we are trying to make a machine as a human brain. So we are intelligent, making machine as an intelligently to take decisions or something to do or to perform certain task basically. So now what we are going to do from this 2D array, can we get some numerical or statistical features, or it may be handcrafted. We call it some kind of handcrafted features with respect to computer vision. But now we are working in case of deep learning features. So I'm not going into detail of what is between handcrafted and deep learning features, but but what is going to happen here basically, there will be a 2D array. From this 2D array, we go with the some kind of features, statistical features, maybe a mean or standard deviations or skewness kurtosis, or it may be a key point descriptors, or it may be a the heraldic texture features, or it may be a, so there are several features are available with respect to computer vision features. So you try to convert this 2D array into an n-dimensional numerical vectors. So that will be an unique between the the cat and dog. So basically, because when you look at all this pixel intensity, this these are the pixel intensity values between 0 to 255, and there will be a basically, if you consider as a color images, it's going to have a three matrices consist of, the depth will be 3, red channel, green channel, and blue channel. So here whatever I represent is a single 2D array, but usually it's going to have a 3 2D array for the color images. Okay, so from this 2D array, as I said, this pixel intensity is going to change with respect to several challenges. Let's see what are the real-time challenges with respect to image or video analytics. So usually when you work with the video analytics, assume that we are working with the CCTV camera footage. There may be a camera which kept on the the top mounted in the wall, or it may be a side angle, or it may be a frontal angle. Okay, so consider a simple example. In this case, where I'm going to perform a face biometric, face recognition in a classroom. Okay, so instead of manually taking an attendance, can we make a systems where automatically, based on the hours and the day, based on the calendars, like can we automate this process instead of every hour machine can automatically does the job. So assume that as a business use case. Okay, so in such business use cases, where there are cameras are available in the side angle, or it may be frontal angle, so human faces may look, he may rotate his faces, right? So the same face images might look different when you capture the same images in a different angle. So the why I'm talking about all these challenges, basically our model, our AI systems has to handle all these challenges, which is a very prominent. It has to be in robust, or efficiency wise, it should be an accurate basically. So this is whatever I'm showing here, which is a Raspberry Pi board. It was captured, the same Raspberry Pi board captured on the different angle. So if you look at here, the object may looks different when you capture the same object in a different angle or the orientation. So here, so that was the main reason. So we don't feed only single or 10 or n 100 or 1,000. So we go with the lakhs of data or millions of images when we build a deep learning systems usually, and then to machine to understand the different objects. So here one of the challenges is the angle or the orientations. So coming back to the next challenges, so I have worked on some of the business use cases, which is called kind of smart parking solutions. So the smart parking solutions, basically it has to work in the the daylight scenarios basically. So it may be a morning or it may be a night scenario. So how it's going to be solved with respect to the business use case? Let me show you quickly the video. So in that particularly the particular business use case, see, can somebody host help me, because I don't see the window to share all the screens.
Oh,
Every time I should stop and I have to go to the window.
okay, sir. Just
Actually, that was happened, sir. You have to minimize the first window. You have to select the second window. So that's what means.
No, there will be option to all the screens, but I don't see that options at all here. It's okay. Maybe I'll. every time I have to stop and go select the particular bin. So if you look at here, this is the business use cases which I'm working actually. This particular the business use case here, to detect the vehicles. So, detect the vehicles and then also differentiate between the car and the two-wheelers. So for these particular business use cases, we have built a deep learning based model which we have collected our own data, and then we made a structured data, and then we developed a deep learning based models which can detect between the car and the number plates. So if you look at here, so it will also try to localize the ROI or the regions where the number plate is present. And then the next phase is that basically, so in such use cases, why I'm coming back here basically. So these are the systems where we should consider, like because the office premises may run for the 24/7. So how your system is going to react in such an environment. So the lighting conditions in this case, you if you look at here, the quality of the images, when you look at here, the quality will be look brighter, right? But we cannot expect the same quality of the images in the night visions, right? So the quality may affect. So in such cases, how your model is going to be, do analytics on those frames and identify the cause and extract the number plate. So if you look at here, the another one, let me show you. So this is going to be this particular video. It's going to be perform the number plate extraction. So basically here we are working on with improvising the accuracy of the number plate character recognitions. So in this case, the number plate character recognition, there are similarity between the we can say like kind of faces. If you say the twins, right? So there may be a high similarity ratio between the twins, right? Similarly, here there is a character similarity between M and N and O and 0. So in such cases, how our model is going to know the minute differentiation has to be captured. So in such cases where we have to increase our training data and then you retrain your models. So first you should have an initial trained model and then try to validate how your model is performing, and then based on that probably you can add some more sample data on the false scenario, and then probably you can retrain your models. So now as I said, like our solution has to work in the day night scenario. And coming back to the other challenges here, basically the scale variation use cases basically. So it's basically like the distance between the camera and the object, right? So suppose if you're trying to take a selfie or some kind of pictures, assume that you are going to take some kind of selfie or something, right? So when the person is very closer to the camera, his face region usually will looks larger, right? So if somebody who is far away from the camera, when you are trying to take a pictures, he might some people may zoom in, right? But usually what is going to happen if it is a static camera, there is no features called zoom in and zoom out. Then what is going to happen? The face region will look smaller, right? So in such a use cases, how your model is going to react. So basically here, if you look at here, there are same coffee cup where it is shown in the different scales, though it is the same category, but if you look in the perspective of scale, it looks different, right? So coming back to the next challenges, which is a very common challenges needs to be considered when you try to build a image or video analytics solution. When you work with the live video analytics, it might be an airport or it may be some kind of railway station. The business use case you may consider like a person tracking, or we are working on some business use cases called personal productive equipments. The personal productive equipments in the sense, like with respect to COVID-19, PPEs are like the doctors has to wear all these, windshield, head windshield, or like there are list of components which they needs to be weird. It has to be taken precautions before they enter into the area where the COVID patients are there, right? But in our case, the same use cases we are also considering in our use cases, which is basically what we can say with respect to the manufacturing plant. So he has to wear the safety helmets and the vest and the safety shoes. So these are the some of the the a list of safety wearables has to be weared before the person goes into the particular area or the shop, right? So if I'm as a part of basically from automobile industry, so where there are different shops are there with respect to automobile, like he has to wear the list of like goggles, safety shoes and gloves. So these are the different set of equipments. So when usually what happens right now, it is done by manual validations whether all the employees wears the safety, the equipments. So what we can do, can we replace with the AI basically? So we collected our own data and then we trained a model which can basically, so the same business use case can be also, we can thought of like right now what happens in the basically the signal, the traffic signals, right? Basically what happens, there will be a policeman, traffic policeman, who will be standing in the roads and he will be watching whether the two-wheelers or the bike riders wears the helmets or not, right? So can we have a mechanism in the signals? Can we put some kind of CCTV camera? Can we have a deep learning based model which can detect automatically the persons whether they wears the helmet or not? And we can also, those person who doesn't wear the helmet, can you automatically capture his number plate and send a fine? So we need to be an intelligent video analytics. So we call it an intelligent video analytics, so which can automatically take a decision basically, to, so instead of a human being to do some task, we are making a machine to perform certain things basically. So here the why the points which I discussed about here basically. So if you look at here, we have a dog with the fully visible and the one that which we have very less visible features. So how our AI model is going to handle in such a situations, like it has to categorize both the images are a dog, but the similarity score or the probability one on the left hand side will be the high probability than the right hand side, because the machine will have less features than the, so though there is occlusion, but still the machine has to handle certain the situations. So these are the very few challenges needs to be considered when we try to build a AI based models, especially with respect to image and video analytics. Okay, so quickly, so what I'll do, the business use case, let's assume that here the business use case here, facial emotion recognitions. Okay, so I'm taking an sorry. So here the business use case here basically, I'm taking simple business use case, which is a facial emotion recognition. So for those particular business use case, how do I build a pipelines? What are the steps needs to be considered? Okay, so assume that you have some business use case, so or some applications which you want to build the AI models. Okay, so what are the steps needs to be considered? Okay, so that's what I call it as a pipeline. It may be machine learning or it may be deep learning. Okay, so simple business use case which I want to take about facial emotion recognitions. Okay, so if it is a facial emotion recognition, what are the different types of emotions? First, you need to have a detailed understanding of the business use cases. So I'm saying that I want to perform a 7 different types of emotion, which is happy or angry or sad, like XYZ, right? So once you have the proper understanding of the business use cases, you need to collect the set of data for all these types of emotions. Once you have the different types of emotions for the different age group or different the gender and the different emotions you need to collect. So once you collected the data, then as I said earlier, especially AI systems will have a 2 phases, right? One is a training phase and the other one is an inferencing phase. We call it also testing phase. Okay, so what we supposed to do, the overall data set has to be splitted into training and the testing phase. Okay, so there should be a some percentage of data should be taken for the the testing of your models, or the for the inferencing to validate how my model is performing, what accuracy it is giving, right? So basically, these are the some of the ratios what we used to follow, like 10% or it may be 20% or 25% for the testing. The remaining data will be taken for the training. So the thumb rule says that like more number of samples has to be taken for the training than the testing. So if you are, and one more thing also needs to be considered, like there are 7 classes are there, and each classes the number of sample data has to be uniform. Like if you are giving one classes the 1000 data, and the remaining classes if you try to give 100 or 200 sample data, so the machine will be leads to an overfitting. Or we can I'll tell you, like we'll have a better understanding on the class which has the 1000 sample. The machine will have a better understanding than the remaining classes. So what happens, the remaining classes maybe it tries to the failure or misclassify it. So that's what we call it as an overfitting. So there should be rule has to be followed when you try to collect the number of sample data for each classes or each category which you are trying to perform. Okay. So now coming back to the assume that we are taking the training data. So now, as I said, the raw data in the sense considering an image as a data, usually it will be in 2D array. So from the 2D array, we have to go for an feature vector representation, usually which I talked about the texture, color, and shape. So which I'm talking about again handcrafted features. So basically, you convert the images which is a 2D array into one vector representation. Assume that we'll have a n-dimensional vector representation, and then we are going for an either machine learning or a deep learning or a neural network systems where we train our model. Assume that I'm going for a machine learning. There are two things are there. One is a supervised and unsupervised machine learning. If your data is structured, assume that my data is a structured data where I have a input and output variable, then we call it as structured data. Okay. So now assume that I'm training with the KNN structured machine learning approaches. Once my model is trained, I'm giving the test data and with the trained model. So now we are going to validate the trained model with some of the performance metrics called precision and recall. Okay. So which I'll talk about little detail about what are these performance metrics. So now quickly I'll give you a glance about it, like what is meant by supervised machine learning and unsupervised machine learning. So these are the some of the supervised machine learning. So here let's assume that I'm taking animals classification data set. Animals classification data set. So here the number of sample data for a training of model, there are 6 sample. So the first column which gives the output variable are the class labels. So if it is going to be a structured machine learning approaches or supervised machine learning approaches, where we have to give the output variable. Okay. So either it may be first column or last column where we can consider as a output variable. Okay. In this case, the first column. And the remaining 6 columns here, we are saying it is a feature vector. So as I said, if it is going to be in color images, usually we will have a 6 matrices. 3 matrices: red channel, green channel, and blue channel. So here I'm extracting the mean and standard deviation as a features. So what is this value? Especially as I said, 3 matrices. Red matrix, you take the red matrix and sum up all this pixel value and then divide it by the number of pixels. Similarly, you try to take for the green and blue channel, and similarly for the standard deviation. So here you can increase the shape of feature vector, like considering the more number of features. So in this case, which I consider statistical features with mean and standard deviation, we can also have the skewness, kurtosis, first order, second order. So you can keep having a n number of feature vector. So in this case, a 6-dimensional vector. So from the 2D array, which I converted into one vector representations. Okay, the extracted feature which we are going to feed input to the machine learning model. Okay, so this is the vector representation which I will be feeding into an machine learning. So as I said, I'm going for an k nearest neighbor classifications. So k represent the number of neighbor. How many neighbors for the given test data, we need to identify the closest n data points or the k data points. Assume that first I'm trying to take the k as a 1, which I need to identify the topmost, the closest point, the first closest data points. Okay. So you consider these are the each data point, but usually what is going to happen, here it is in a 2D visualization, but usually it's going to have a n-dimensional data points. So because here we have a 6 as a feature dimensions, right? So now what I'm trying to do, I have a one more row. Assume that I have a one more row with 6 columns, okay? But I don't have a label column, okay? So now what I'm going to do with the KNN, I'll take the first row, all these 6 value, take the sum of difference between all these mean of red channel and the test data mean value of red channel plus a green channel mean value, similarly for the test data. So you take the sum of difference between all the features with respect to trained data and the test data. So finally, what happens? You will arrive at a single d value, which we say as a distance value. Okay. So now what happens? You have taken the first data from the training one, and similarly, you take the second data and you try to compute a Euclidean distance. So what happens? Finally, you will arrive at the n number of distance value based on the number of training data. So finally, what is going to happen? You try to do a sorting of all these, the d value, ascending order, and then you pick the topmost d value, which we'll say is the the closest to your the first closest to your test data point. That particular class labels will be predicted one. So usually what happens, most of them will try to project in a 2D array and then they'll try to say this is the closest point. But usually what happens most of this time, they fails to answer. Like I go into most of the interview to take the candidates, but they fails to answer all these things. But usually this is the internal logic behind how the KNN works. But consider when the k value is going to be greater than 1, assume that I'm going to take the k value as a 5 or 3. So you need to pick the topmost the d value once you have the sorted d value, and take the topmost 3 or 5 based on that. And among the 5, assume that I'm trying to take the topmost 5. So in that category, how many are belongs to cat and how many are belongs to dog? So go for an voting mechanism averaging the majority of presence in the topmost 5, which classes it belongs to. So that will be the predicted class. This is what how it works with respect to KNN basically. So now coming back to the k-means clustering. So the difference between the supervised and unsupervised machine learning, with respect to unsupervised machine learning, where we'll not be having the class labels or the output variable. So assume that you cannot expect when you download some data from the open source or when you collect your own custom data, we cannot expect the data will be in a structured format. Okay. So usually in such cases where we can go for an building an unstructured machine learning model or a supervised so unsupervised machine learning approaches where we can say clustering or segmentation kind of approaches. You can ask machine to group your data into n clusters or n group, and then you consider that particular as a structured data. Manually, you go and check all these clusters, and then if there is any misclassifications which is done by the machines, manually do some validations, and then probably you can consider and have a label for those clusters ID, and then you consider that as a structured data, and then retrain your model with the supervised machine learning. Quickly, I'll talk about how it's going to work with the k-means unstructured machine learning approaches. So assume that this is going to be an data. So if it is going to be an k-means clustering, I'm considering this as a 2 group. Okay. So the number of cluster is 2. Okay. So first step is that first to initialize the cluster centroid. So the first data point I'm considering as a cluster 1, and the last data point which I'm considering as a cluster 2. Okay. So now what I'm going to do, I'm going to take each data points in the training data. So compute a Euclidean distance between the cluster centroid 1. So these data points which I'm going to do a Euclidean distance with the cluster 1 and cluster 2, and then finally you will have a 2 distance value with respect to cluster 1 and cluster 2. So identify which one has the smaller distance value, put that move that data points into that particular group. So similarly, you try to compute the next subsequent data in the training data set, and similarly you try to compute Euclidean distance, right? So somehow you will arrive at the set of data points at the cluster 1 and cluster 2. So now what is going to happen, you compute the cluster average, cluster centroid, taking the average of all the data points in the cluster 1, and then that will be considered as the cluster centroid for the respective clusters. Similarly for the cluster 2. So now one iterations or one epoch is done. So what is going to happen at the next iterations, you take the updated cluster centroid and you try to compute a Euclidean distance with the cluster 1 and cluster 2, and you repeat this process until the cluster centroid doesn't going to change. Okay. So I recommend everyone take some real-time example and demonstrate to the students, so they will have a clear, they can look at what is going to happen with respect to, you know, the clustering, or it may be any kind of, it may be data mining, or it may be, so that so try to teach as much with the real time example where they can easily know, they can understand. So this is what going to happen. So whatever the steps which I said about, like these are the steps which is going to happen. So easily they can write with all these steps basically. So I was talking about the performance benchmark metrics. Basically, I was talking about the precision and recall, right? So before I go into the precision and recall, I wanted to talk about the confusion matrix. If you look at here, this is the confusion matrix with respect to classifications. So here, example which I have taken about the bird classifications, whether the given image is bird or not. Okay. So here the first column will be the ground truth value, or the actual label value, and this the first row, if you consider here, this is the machine predicted value. Okay. So now what happens here? There are 598 samples. 598 sample, which is actual class labels are bird, and the machine is also predicted as a bird. So both the classes are belongs to a true classes. So we call it a true positive. Okay. So now coming back to, there are 8,908 samples are classified as a not bird. Machine is also predicted as a not bird, and actual value is also not bird. So this we call it a true negative. So coming back to a false positive, actually it is not a bird. In the given visual images, there is no bird presence, but machine is predicting as a bird category. Okay. So now, not bird, actually it is a bird. Hello. Is that my voice visible? I'm getting some unstable internet connections.
No, sir, it is clear only.
Clear.
It's clear, right?
Yes, sir.
Okay, thanks.
Yes, sir.
So now what happens here? Basically, actually it is a bird data, but machine is predicting as a 409.
Sir, పెట్టారు internet.
Ama, Tefila, I think he is left. You have to ask him to join again.
Problem పోమాటిక్.
Sorry, actually, due to network problem, I got dropped.
No, sir, no problem, sir. Continue.
No issues.
So here I was talking about the confusion matrix. So basically, so here we are the false negative. The machine giving more number of false negative, right? So there are 402 sample, which is actually it is bird, but model is giving us a not bird. The reason is that the machine, the number of sample data, the machine is given. There is a more number of training data is given for the not bird category than the bird category. So that was the reason why the model is not performing well on the bird category usually. So there is a more false positive. So as I said, like the uniformity in the number of class sample data for each of this category has to be an unique, so that your model will not overfit in such cases. So now what I'll do, I'll go into quickly some of the demo which I want to showcase. I have 2-3 demos, then I'll go into for the QA sections. Just give me a minute. I'm running the script. Let me share. So this is the live demonstration which I'm giving about. Can someone confirm? Is that my output window visible?
Yes, sir.
Okay. So this is an which I talked about.
Output window, the image.
It's actually live streaming,
Video.
which I'm performing as of now.
Yes,
So if you look at here, so basically, which I'm running from the live stream, which is basically tries to classify whether the person is wearing an face mask or not. Basically, so it tries to categorize between the person wearing an face mask and without face mask. So already I have the trained model. Based on the trained model, it tries to classify whether the person is wearing an face mask or not. Okay. So I have a few more demonstrations. Let me run one by one. So is that my screen visible?
Yes, sir.
So here, basically the drowsiness detection. So it's basically with respect to the driver drowsiness detections. So we have to identify whether a driver feels sleepy or so. Can we use some kind of AI based systems which can alert when the driver goes in a drowsy mode, basically. So here we used some kind of ER based mechanisms, eye aspect ratio. So I'm not going more about it. So I have one more demonstrations. Let me show you. So the another one which I'm going to demonstrate about the face biometric authentication. Already my face is trained actually, but still I have not trained on this particularly with respect to my home environment. Most of these data are collected as part of my notes I did at part of my PhD I have did. I have trained deep learning based systems. If you look at here, in the, it will try to predict whether it belongs to a known or unknown persons, but most of the time it says as a Morgan, but the similarity gives for the Morgan as the majorly priority, right? So if I want to give a more accuracy on this particular environment, the training data has to be given the environment which I'm setting as of now, right? So but the data even I have not collected as a part of this particular environment, but still my model or my mission is trying to categorize as the particular persons. So the last one, before I end up with the sessions, probably I'll take few questions. So this particular use case is basically, one second. This particular use case is to count the number of people which they are entering into the particular premises. Basically, if you look at here, it is performing the person detection followed by the person tracking also. Each person will be assigned with a unique ID, and also we are trying to compute in which directions people are moving, whether they are entry and whether they are exit. So these systems can be applied many places like cafeteria. So if with respect to COVID-19 situations, right? So only very few peoples are entered inside, right? So we should have the count of how many peoples are inside. Based on the exit, we should know, decrease the count, right? So basically, the person detections was used with respect to deep learning and combination of image processing to track the persons, and then we will be able to build such systems. So I think I'm done. So because I'll take another 5 minutes quickly, probably. No, I can take a QA. So let me check. There is the chat. Hello.
Sir, tell me, sir.
Yeah, ma'am. Can you with the questions? Can you read out some of the questions from the participants?
Okay, sir. Yeah. Aparna?
Okay, ma'am. Thank you, sir, for sharing your knowledge and experience. Now, on to the Q&A session. Sir, can you tell about any artificial intelligence model for content-based video retrieval?
So basically, there are 3D CNNs are available, especially what I work with respect to human activity recognitions at the what I worked actually. You can also work a combination of CNN plus LSDM kind of deep learning models, the spatial temporal information where it can be captured. And probably there are a deep learning research article exist with respect to video based classifications I've worked. But similarly, you can also use the same video classifications model for the retrieval as well. So you can go through about 3D CNN with respect to video, and also you can go for an CNN plus LSDM combinations as well. So LSDM, especially for the time sequence informations, where you can use LSDM kind of models, where we can say about recurrent neural networks, basically.
Thank you, sir. What do you mean by pipelining and emotional facial recognition in artificial intelligence model?
I think I forgot to show the demo. So quickly, I'll show you the demo. I'll share my screen. So I have shared my screen. So this is the live demonstration. So this was the model which trained on the different types of emotions. So basically, these are the facial expression recognitions can be used in AR augmented like this. I'm not, I cannot do all these emotions, but this particular model was trained on the basically 7 different types of emotions, basically.
Okay, sir. Thank you. What is the accuracy level in emotional facial recognition?
See, the accuracy, what I could say, like depends on the data, and also like what kind of deep learning models you are using, how many layers, and the number of sample data. So that all these things, considering your accuracy may vary. But now with respect to classification problems, people are reaching out more than 90%. Basically, there are pre-trained models. See, I'm not gone into more deep of deep learning and stuff, but it needs actually to teach and to make you to understand, usually I give 2 days of training, usually I do, but if you want to work on quickly, if you want to build some deep learning architectures, there is a concept called a pre-trained model. We call it as a transfer learning. So basically there are pre-trained models on the ImageNet data, where you can use the existing trained model. You can remove the last few layers, because that particular model was trained on the 1,000 classes or their respective business use case. If you want to fine tune for your own business use cases, you can fine tune very few layers with very few data.
Thank you, sir. What is the difference?
I'll be giving my Git. I'll be posting it my Git URLs. There are lots of Git repositories are there. Probably you can go to that my Git repo. And especially I work with the Google Colab to train the models and to give the hands-on training or to practice. So I have posted my Git URLs in the chat window, and also I'll give you the link for the Google Colab to practice it's basically an environment which they have given free of cost with the GPU environment, and all these libraries are pre-installed basically.
Okay, so thank you. What is the difference between SVM and multi-class SVM?
Aparna, repeat the question, sir.
Okay, ma'am. What is the difference between SVM and multi-class SVM?
Again, sir.
Sorry, there was some network issues from my side.
Okay, sir.
Hello?
No issues, sir. Aparna, repeat the question, ma.
Okay, ma'am.
No, I got the questions. Basically,
Okay,
so you can either use, if it is going to be a binary classification, then you can go with the one class SVM. So one of the my research study which I used, the linear SVM basically, which I used for the whether the given face image or whether it's a face or non-face images. If you're going for a more than one classes, then you can go for a multi-class. But even in that, you can use a kernel functions, which is RBF, or you can use a linear kernel. So there are parameters are there where you can fine tune with your data.
Thank you, sir. Why we go for mean and standard deviation of color features? What is the significance of it?
See, basically, as I said, these are the very basic features which I said about it. But usually we have to convert all these raw data into one vector representations. Okay, so either it may be texture, or it may be color, or it may be key point descriptors. So we have to convert all these raw data into one vector representation. So which I said about it's very basic features. It's not going to give a better accuracy at all. So basically my intention is to convert all these input data into one vector, and then the extracted vector value will be given to the ML models. So my intention is here to say about feature vector. It may be any kind of features. You can have a n number of such features basically.
Thank you, sir. What is structured data in traffic density?
See, basically you can say about normal and abnormal basically. Recently, even maybe somebody who is interested maybe reach out to me. I know one person along with me, he did a PhD in traffic density classifications like abnormal and normal. The directions he did his PhD on that. But I'm not more into that particular business use cases. Maybe if you're interested, maybe I can connect with him. You can say about the directions in which he is moving about normal or abnormal, which I can say about the traffic density. I have not worked on much on that particular business use case. Maximum another 2 questions. Probably I need to switch to other meetings.
Okay, sir.
Hello.
The next question. Okay, sir. Thank you. In automation license plate detection and recognition, at times we get a different information instead of the actual case. That is, if the actual number is TN36AQ2675, but if the model detects and displays output as TX36XX2675, what is the significance of selecting the dataset as 70 for training and 30 for testing? Which feature of selection method is used here?
See, basically what I used, basically there are object detection models are there, which I use as a YOLO as a object detection model basically. What I did actually, I took each character as an individual object. So basically we have taken a 35 classes, but there will be actually 36, 26 as a alphabet, and basically one more 10 character digits. Basically there is a 36, but 0 and O we made as a one classes because there is a very similarity. But what happens basically, you can increase the number of sample data in which scenario your model is. As I said again, you try to collect some amount of data and then train your model and validate how your model is performing in class wise, where you need to compute accuracy. Basically 0 digit what is accuracy, 1 digit what is accuracy, and then which digits falls very less accuracy, probably you can increase the number of sample data and then retrain your models basically. See, at the first initial level model itself, you cannot achieve. So you have to keep fine tuning your models for so it's not like a month or you can do. So usually we work a product for more than 6 months. So and then deployment, usually we work to make there is a maturity. It will take usually 6 months to 1 year actually.
Okay, sir. Thank you. How to relate accuracy with other performance parameter? One classifier attains good accuracy rate, but it will not be good in precision and sensitivity. How will we say whether it's good or bad?
See, basically, if you ask me, like with respect to classifications, we go with the precision and recall and the confusion matrix. So these are the sensitivity. We have not done it, but usually we go with the precision and recall and the confusion matrix. And also one more thing, what we look at the perspective of model, how it is fast. Because you if you build a deep learning model with the 200 layers or 1000 layers, if your model is not going to perform in the real time, we are not should restrict into accuracy alone. We also has to consider how your model, what response time it takes to give the output. So that is also important things we need to consider, right? So we won't consider the accuracy point of view alone. We have to see how the production in live is going to produce the results. So if it is a point of research, but you may not think about it, but as a point of the product level, we work on both accuracy as well as the time response time. But if it is going to be an accuracy point of view, where usually we calculate with the classification point of view, it's going to be in precision and recall. If it is object detection, we go with the IOU. Basically you can take a mean average precision basically, or IOU you can calculate. With respect to business use cases, the metrics is going to vary basically.
Thank you, sir. The last question is, how do you
Maybe
see...
I have posted my 1 second, ma'am. I have other meetings which is scheduled, so I need to join there. So probably I have given a mail ID. If you could forward, you can ask the participants to send the mail. Probably I could respond in a
Okay,
day,
sir. Okay, sir. Sure, sir.
because it will be difficult to respond to everyone questions. Maybe I can offline. I
Okay,
can do
sir.
that.
Okay, sir. Yeah, sure. Thank you. Thank you, sir. Thank you. Aparna, go on with the vote of thanks.
Thank you, sir. And now it's time to express our gratitude. First of all, I extend my most sincere thanks to the Almighty for making today's event a resounding success. I extend a hearty thanks to Dr. Mohanraj Venkatachalam, sir, in helping us gain knowledge and good understanding about automation and artificial intelligence. Once again, thank you, sir. I also thank our head of the department, Dr. C. Vyana Kausalya ma'am, staff and student affairs, Dr. G. Rohini ma'am, lab affairs, and all other faculties for organizing this event successfully. Last, I thank all the active participants for your support. Thank you.